Hello and Jai Hind everyone. I am Bhavya Kumari of Sunbeam School Lehertara of class 10E, here to tell you how such a common and minimal thing like soap can have such a wide and interesting concept of how it works. We use soaps in cleaning our clothes, in washing our hands and cleaning surfaces. But have we ever wondered why does it clean and how does it clean? Well, I am here today to solve all those questions. So first of all, we get to know about what soap is made of, what is its composition. So the soap that we use in our daily life is made up of NaOH, which is a strong base, and fatty acids, which are found in oil, and glycerols. The process of making soap is known as saponification, which is formally defined as the reaction between a strong base and fatty acids to produce soap and glycerols. Now you must be wondering, how does the composition actually look on a molecular level? Well, this is how soap actually looks on a molecular level. It has a head and it has a tail. The head is hydrophilic, which means it loves water, and it is polar as well. And the tail is hydrophobic and non-polar, which means it will not love water, it hates water. And the chemical formula for soap is C17H35COONA, in which Na comes from the sodium hydroxide that we used and the rest comes from the fatty acids. Now let's see how does this composition actually help in cleaning. So to answer the previous question, the soap form a formation like this, which is known as micelle formation. In this, the non-polar side will attract to the non-polar dirt molecules which have oil in them, and they will run away from the water. Why? Because they are hydrophobic, and they will attach themselves strongly to the dirt and the oils. Whereas the polar ends, which are the head, they will attract towards the water. Why? Because water is also polar. So now when we will add friction, there is another thing that will happen. When we add friction, the dirt will now lose its strength towards the cloth and it will start detaching itself. And when it detaches itself, since the micelle formation is strongly attached to the dirt will start to come off, and since the polar ends are attracting, it will get mixed in the water. And tada, we have a clean cloth. And now how do we use all this in our daily life? Well, the best example would be cleaning a dirty cloth. Here we can see there is dirt, which is non-polar, and here we have soap solution. So when we start to clean the cloth in the soap solution, slowly and slowly we can see that the dirt molecules are starting to get mixed in it. Why did this happen? Because of micelle formation. And now when we add friction, the dust and dirt will start to lose its strength on the cloth, and we can see the water has become dirty. That means the cloth has been cleaned. So now we can see if the cloth has actually been cleaned. And here we have, the soap has done its magic. So this was the chemical process by which soap cleans dirt. And by this we can say that science is actually in our daily life, but we tend to ignore it. That is why we should know more about science in daily life. Thank you and Jai Hind.